profitable. It was very good to be just after the speech of Mrs. Alexandra Mosch, because she referred to bioprocessing regularly. And we can also say that we have mastered some of the pieces of the game, but there's still a long way to go. But I would like to share with you what we have mastered until now. In bioprocessing, for me, it's very important to understand what you want to produce. There's a lot to produce out of seaweed, but you need the right partners specifying for you the demand of the product they want to apply. And if you know what they want and you can select your biomass or your seaweed species in this case, then you get into your cockpit of control parameters and you try to operate a bioprocessing facility which converts biomass to the product that the off-taker would like to get. So we've looked in literature and we've looked at what all is done in science related to seaweed processing. And what we learned is that there is a lot of research going on, but 90+% of the projects start with drying seaweed, storing it in a cupboard, and then taking it into a laboratory. And very often it's one species of seaweed. Real world, of course, will never be able to dry huge quantities of seaweed. So that is a hurdle. Then the research focuses many times on one extractant, which often goes together with relatively low yields, but unique specificities of those extracts. There's very often no integrated flow, and there is very limited link to the higher demands in logistics, because huge volumes of seaweed to the laboratory is impossible. So we need to do something about that. The R&D was many times leading in the science, not the entrepreneurship. There's a poor refinery skills in most of these sciences. They take the dried seaweed out of a cupboard and that's where the process starts. There's a limited customer involvement. Like I said, you need to know what you need to produce before you get anywhere. There's a weak vision on sizing, and there's a big focus on floating and wild seaweed harvested, not really on the production. All these learnings were relevant, but our approach has been different. We have shifted to using fresh seaweed to control logistics, to control energy input cost for drying or freezing, and very important, to control the food grade status and the sustainability. The design of the best-in-breed consortium. So what does the customer want to buy and what specifications do they want? And then there is a very clear statement that the technology for bioprocessing is not the issue. The required hardware that you need for seaweed bioprocessing all exists. Seaweed has the benefit that it does not have these hardy, cellulose-rich, woody components. So you can use a lot of mild technologies to do bioprocessing. The most interesting one, and Alexandra Mosch also referred to that, you need to cascade the extraction of products. And why do you need to do that? You need to get as much as possible value out of each and every kilo of seaweed until the day that seaweed gets as cheap as other commodities like sugar or corn. We need the cascaded bioprocessing. So the process we have today is we harvest seaweed, we wash and slice, preferably offshore, and we start the processing offshore. Then we transport the material, the size reduced and washed material to the harbor. And back on land, we separate the water, which now contains the protein, from the remaining solids. The protein is one of the key valuable products that we retrieve today from the seaweeds. And we do that by removing the water as well as the minerals from what we now call the functional proteins. We've really proven some functionalities that nobody has ever seen yet from the dried seaweed or frozen seaweed taken out of the cupboard. The next is, of course, you have the solids left. You can still extract alginates, carrageenans, or others, but you also have the option to go for total hydrolysis and make a sugar broth and go into a fermentation process, for example, which we've done for biogas, bioethanol, and we're actually working on some of that into bioplastics. So in this technology, you have functional proteins, which is a high value product. You have the option to extract alginate or carrageenan, which is today a commodity bulk market. And you have the option to go into biopolymers or renewable energy. Why do we do these steps? First of all, we reduce the logistic volume by slicing offshore and processing offshore. We leave the fauna in the habitat where the material is harvested. Also, important topic for NGOs to do not destroy the biodiversity there. We use the logistic time to harvest and bring it to the port as part of the processing time. We avoid drying and freezing energy input, which is a big issue for sustainability concerns. And most important for me is that we preserve the high food grade quality. We don't have logistic time which digests or destroys the food grade perspective. We also remove minerals and contaminants in the process water. We have really achieved, the previous question was the heavy metal discussion. We've really removed some of the heavily contaminant minerals out of the biomass and out of the protein into the wastewater. And that way we also can claim a cleanup of the environment. We use existing hardware, as said before, and we have simplified many operations by using ambient temperature, ambient saline conditions, and ambient acidity conditions. And we keep for the whole process the flexibility of input and output. We've done it on many seaweed types, and we are talking to off-takers on what they want out of that seaweed. So cascaded value extraction for us is crucial. We do that mainly today with protein and energy transition in mind, in perspective of the Paris agreements. We be flexible in traction because we want to start small and we ultimately want to become big in volume and operations. We work with fresh material, which we convert in multiple fractions. The right seaweed mix is essential to get year-round. As Professor Jaric mentioned, they have in North America the options to go for Gracilaria and kelps and have a year-round coverage. That typically is important for a biorefining process. You cannot have a biorefinery that works for 3 or 4 months a year. With the proteins we extracted, we've been into the baking market, in the sauces and dressing market with the seaweed protein, in the dairy replacements, dairy alternatives, and all of them showed good performance. The balance between fresh products and low offshore costs is a hurdle that we need to take care of and requires a lot of optimization. How fresh is fresh seaweed is a key question. We like to operate near shore, but if we want to have a good environmental impact. For us, it's crucial, since we are a bioprocessor, we are not a seaweed farmer, we are selecting the right farmers. Technology to bioprocess is for us no longer an issue. We have an experience, and we need farmers who have an experience in vision and upscaling. We need to have a tangible roadmap of cutting farming costs drastically. In Europe today, from 700 euro per wet weight ton, we hope to get below 50 euro per wet weight ton. Mechanization and lab breeding, already mentioned by previous speakers, are important for cost cuttings. And as mentioned, multiple year-round species farming is still in its infancy, but crucial for the future. The challenge is to match small entrepreneurial seaweed farmers today with the industrial big entity demands. A different picture of why we do it. If you want to eat beef, you have a big impact on land, freshwater, and greenhouse gas emissions. If we go for seaweed bioprocessing as an alternative for beef protein, then we have a negative impact on all of this. Top priority for us in upscaling is only the volumes help to impact the sustainability development goals. Only with volumes of seaweed and perspective of big players the big players will step in, and it will help us all out of the valley of death. Only with firm supportive policy targets from governments will take us beyond just being likable. And we cannot expect the small entrepreneurial businesses of farmers today to drive these big number changes. Just to give you an example of big numbers, we have created a business case on demand of some of the Dutch authorities, and one bioprocessing plant near shore in the Netherlands will require 20 to 30 square kilometers to produce an annual 500,000 tons of wet seaweed per year. And such a volume of seaweed will deliver about 20 million cubic meters and about 6,000 tons of functional proteins. Just to give you a picture, if you want to be integrated into a multinational food business, you need protein volumes in that range. And these are the indicative numbers of investments and revenues. Next for us is create consortia of people who have a demand of seaweed products. Today, we are focusing on protein and renewable energy, the number one in this line. We have discussions going on with consortia to have protein, alginates, a medical compound, and biogas. And we go on in our developments. And what we want to do is to create these consortia who have a need for seaweed constituents. Hopefully, also mentioned by earlier speakers, CO2 taxation will help us to get these developments triggered. I also would like to draw your attention to a Dutch seaweed market overview, which is sponsored by 3 government authorities, which will happen next March 11. You need to get registered through this email address. You can ask me. Thank you very much for your attention, and I'm looking forward